So this was a pop quiz 25 related to organic chemistry. The first question, um, we have a compound. Zinberine is a compound that gives a ginger its characteristic flavor. And the IOPIC name is given 2-methyl, 5,6-methyl, hept 5-ene 2-yle, cyclohexane 1,3-diene. On the structure, draw a circle around the 2-methyl group refers to an IOPIC name. So we have to, on this structure, we have to circle which one is refers to 2-methyl. If you see, we have a cyclohex 1,3-diene. So this is cyclohex 1,3-diene because like 1, 2, 3, 4, 5, and 6 carbon atoms are there. And with this, because this is a main structure, cyclohex 1,3-diene, this is a main structure. And with this, what are the groups attached? We have second position, methyl is attached to this. And fifth position, we have this whole attached. So this is a main, because whenever organic compounds, what is there at the end is representing the main structure. So main structure is cyclohex 1,3-diene. So this is cyclohex 1,3-diene. Now, second position is a methyl group is attached. So this is a methyl group because when single carbon is there, so this is a methyl group. And this position we have, like this is a fifth position. So how we can number this, like if we have 1, 2, 3, 4, 5, and 6. This first, second, so fifth position, we have this whole group, which is 6-methyl hept 5-ene 2-yle. This is this part. And 2-methyl is attached here. So we have to circle the 2-methyl group. Like 2-methyl means the second position methyl group is attached to a cyclohex 1,3-diene. That is, this one we have to circle. Then deduce a molecular formula. How to deduce a molecular formula? Because this is a skeletal formula. So from the skeletal formula, how you can reduce the molecular formula? This is one carbon is there. And because one bond is formed, so this is CH3. This is one carbon and one bond is formed, so 3 hydrogen will be there. This is one carbon and 1, 2, 3, 4 bonds are already formed, so there is no hydrogen here. This is 1, 2, 3, so there will be 1 hydrogen. This will be CH2. This will be CH2. This will be CH, because if carbon maximum can form 4 bonds, if how many are bonded with other, remaining will be hydrogen. So this will be CH3. This will be CH. This will be CH2. This will be CH because 1, 2, 3 are there. This will be C only because 1, 2, 3, 4 bonds are there. This is CH3. This is 1, 2, 3 are there. So CH. This is 1, 2, 3 are there. So CH. So then what we have to do, we just have to count the total number of a carbon and hydrogen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So C15 are there. How many hydrogen? 3, 6, 7, 8, 9, 10, 11, 12, 15, 16, and 18, and 22, 23, and then makes 24. So it will be C15 and H24 will be the molecular formula of this compound. Is it clear, this part? So to work from the skeletal formula, how we can work out the molecular formula? If it's having one bond, it means 3 hydrogen will be there. If 2 bonds, 2 hydrogen will be there. If 1 bond, then 3 hydrogen will be there. That's how we worked out the skeletal molecular formula from the skeletal formula. When it reacts with an excess of a hydrogen bromide HBr, there are a number of possible products. The structure of the major products are shown. The methyl part, look, it is written cyclohex 1,3-diene. So mean this is the main structure, okay? And with this structure, two branches are there. One is the branch attached with the second carbon, which is 2-methyl. Another branch which is attached with the fifth carbon, and this is the name of the branch. So two branches are there. This is one of the branch, and this is the second branch. In the question, we have to circle the methyl group. The 2-methyl group referred in the IUPAC name. So means this group which is referred here, 2-methyl group means like the second carbon which is having a like second carbon of cyclohex 1,3-diene, which is having a methyl. Yes, the main structure is always at the end. Next is, it is reacting with hydrogen bromide, and there are a number of possible products. The structure of a major product is shown. Name the type and the mechanism of the reaction. Whenever alkene, as we discussed, alkenes will undergo electrophilic addition reaction. So, and if the free radical substitution is for alkane. So name the type of reaction, electrophilic, and the mechanism is addition. So alkenes undergo electrophilic, and whereas alkane undergo free radical substitution reaction. The diagram shows a simplified structure of zinc-brine in which part of a molecule is represented by A. Complete the mechanism for the reaction with one molecule of hydrogen bromide. Include curly arrows, any relevant dipoles, and the lone pair. So electrophilic, we have to actually show the electrophilic addition reaction mechanism. So first what will happen, like example, if I draw HBr here, and this part is shown to us where the bromine is added, like this part, if you see, this part is shown, given to us, this part. And a bromine is attached with a carbon which is having one group. Like because this is a major product, because when carbon cation surrounded by more alkyl group, it is more stable. So we have HBr here, so hydrogen and bromide. Bromine is more electronegative than hydrogen, so there will be partial negative on the bromine and there will be partial positive on hydrogen. That is the first thing. Then what will happen? This double bond, the hydrogen is attracted towards this double bond, and bromine will take both of the electrons which are involved in the bonding between hydrogen and bromine. What will be the intermediate? So we have to do the skeletal formula. Look, the hydrogen are added toward the side where we already have more hydrogen, or the carbon, because two possibilities are there. If I show, we have to show a major product, but if I represent the two possibilities of this one, the carbon cation, when the double bond breaks. So when the double bond breaks, we may have this as a carbon cation, or we may have this as a carbon cation. But which carbon cation is more stable? How to identify? The carbon cation which is surrounded by more alkyl group is more stable. So here, how many alkyl groups are there? This is one, and this whole is considered as one. So two alkyl groups. But when we check this one, so one alkyl group, the second alkyl group, third. So means this structure is more stable, because alkyl groups are electron releasing group. So the net positive charge on the carbon cation reduces. So that's why this won't happen like this, because we are completing for a major product. So what actually happened, this will be the distribution. Hydrogen in a skeletal formula, we don't represent the hydrogen. That's why it's attached. So hydrogen, even though it is attached here, but we don't represent that hydrogen. Then what will happen? As the bromide ion is formed, because the bromine took both of the electron pairs. So this bromide ion will have a lone pair of electron. You can draw a hydrogen here, but if you don't draw, that is also fine, because it's a skeletal formula. It just shows the functional group and the carbon chains. If you want to draw hydrogen, that is also fine. Then this lone pair is attracted towards the carbon cation. When it is attracted towards the carbon cation, then what will the structure? So here we attach hydrogen and here we attach bromine. This is the final structure of an A. Why this A means like we have to write because it shows the whole structure is just a part of a structure which undergo electrophilic addition reaction. How the marks are distributed? When you show the polarity on the bonds of a hydrogen and a bromine, you will score 1 mark. When you show these curly arrow, complete arrow, you will score the 2nd mark. When you draw this structure, you will score the 3rd mark. And when you show the electron lone pair on the bromide ion and attracted towards the positive, you will score the 4th mark. Is it clear? The mechanism? Electrophilic addition reaction. So this always remains the same. This has always happened in electrophilic. The major and the minor products you should be able to complete. If the same question may be minor product as well. For the reaction in C2, there are two possible products, as I mentioned, major and minor. Explain why. The first one, this is a major product, and the other one is by referring to your mechanism. So as already mentioned, a reason why the first one is a major product, because in the first one, the carbon cation which is formed is surrounded by more alkyl group. Or you can also say it is a tertiary carbon cation. Why it will be a tertiary carbon cation? Because when this was a positive here and this was a positive. This is a secondary carbon cation because 2 carbon chains here. This is a tertiary carbon cations. So the first one you can say tertiary carbon cation, or you can say in the structure, the first structure carbon cation is surrounded by more alkyl groups which are electron releasing groups, and they reduce the charge on carbon. And when they reduce the charge on the carbon, as a result, the carbon cation become more stable. Then identify the catalyst. Basically, what happened here? Here, all the double bonds, alkene is converted into alkane. And what reagent is added? It means hydrogen is added because alkene plus hydrogen gives alkane. What are the reaction conditions for this? We should have a high temperature. This is called hydration. Hydrogenation means hydration means addition of water. Hydrogenation means addition of hydrogen. So what is the catalyst used for this reaction? We use nickel as a catalyst. You can say Rennie's nickel, or you can also say nickel. Like finely divided or small pieces of nickels, or you can simply say nickel. Then we have a general gas equation. We have 2 moles are there which react completely with hydrogen at 150 degrees centigrade and 120 kilopascal. Calculate the minimum volume of hydrogen needed under these conditions and stating your units, the ideal gas equation PV is equals to nRT. So how we can work out this equation? First, the unit conversion is important. So we need the volume. So if we need the volume from this equation, so the volume will be equals to nRT divided by P, where N is representing the number of the moles, R is representing the general gas constant, T is the temperature, P is the pressure. But we need the volume of hydrogen, like 2 moles of zinc-brine react with completely with hydrogen. We have to calculate the volume of hydrogen. So We don't have the moles of hydrogen. We have V is equals to nRT over P, but we don't have this N. How to get this N? So for this N, you have to check the ratio. Like how many hydrogen do I need? How many moles of hydrogen do I need? So here is a double bond. So this, I need 1 mole for this. Here's a double bond. I need 1 mole for this. And here's a double bond. I need 1 mole for this. The ratio, which means how many moles of hydrogen I need here. I need 3 moles of hydrogen. If 1 mole is there, 3. But in the question, we don't have 1 mole, we have 2 moles. So if we have 2 moles, how many moles of hydrogen are needed? We need 6 moles, because the ratio is 1 mole of this compound react with 2 moles of hydrogen. So if we have 2 moles of this compound, how many moles of hydrogen will be 1 mole of this compound react with 3 moles of hydrogen. So if 2 moles of this compound, how many moles of hydrogen will be there? X, we cross multiply, we get 6 moles. So using the equation PV is equals to nRT. So we want substitute 2 here. So nRT over P. When N are the number of moles, 6. R is the general gas constant, 8.31. T is the temperature, must be in Kelvin. You have to show how it is converted to Kelvin at 273. Or directly you can write it here, 150 plus 273. Divided by the pressure. Pressure is in kilopascal. It must be in Pascal. So it will be 120 into 10 power 3, because we convert the kilopascal into Pascal. So unit conversion is always important. And when you get the answer in general gas equation, you will always get the answer in meter cube, not in decimeter cube. If you want to convert into decimeter cube, then you will multiply by 1000. So example, when we solve this, we get 0.175 meter cube. And if you want to convert, we multiply by 1000. So it will be 175 decimeter cube. Is it clear? This question, how we worked out the volume of hydrogen reacted. So this was a pop quiz 25, which was related to organic chemistry.